Good evening, ma'am. This is K. Pranavi. My roll number is 234J1A0488. I am from ACA B section, and my topic is triple integrals in multiple integrals. So, how to solve a problem from region of integration in triple integrals? So, in this session, we'll learn how to solve when a region of integration is given in triple integrals. So, when an integration is given and the limits are given, when they ask us to find the region of integration, we'll follow this kind of method actually. So, let's see the question in the region of integration in triple integrals. Evaluate integration of R x plus y plus z of dz dy dx, where R is the region bounded by the planes x equals to 0, x equals to 1, y equals to 0, y equals to 1, z equals to 0, z equals to 1. So this is the question they given. So the given integration is I equals to triple integration R of x plus y plus z of dz dy dx. So according to the question, the given limits of I are x equals to 0 to x equals to 1, y equals to 0 to y equals to 1, z equals to 0 to z equals to 1. By applying these limits on the integration I, we get I equals to integration x equals to 0 to 1, integration y equals to 0 to 1, integration z equals to 0 to 1 of x plus y plus z of dz dy dx. By applying integration on dy, we get that integration of x equals to 0 to 1, integration of y equals to 0 to 1 of xy plus yz plus z square by 2 of 1 0 to 1 limits dy dx. Here we applied the integration on dy. That is, if there is no variable of in integration, if the integration is 1 into dz, then the value is z. If it is given in a power like integration of a power n into dn, then we'll write that a power n plus 1 by n plus 1. So here, on applying those formulas in this equation, we'll get that x equals to, integration of x equals to 0 to 1, integration of y equals to 0 to 1 of applying those one higher and lower limits, we get that x plus y plus 1 by 2 minus 0 of dy dx. Then after solving, we'll get the equation I equals to integration of x equals to 0 to 1, y equals to 0 to 1, x plus y plus 1 by 2 of dy dx by applying integration on dy. So after that, we'll apply the integration on dy, that is on y variable. So we'll get that integration of x equals to 0 to 1 of xy plus y square by 2 plus y by 2 of 0 to 1 limits dx. After applying lower limits and higher limits, we'll get I equals to integration of x equals to 0 to 1 of x plus 1 by 2 plus 1 by 2 dy dx. By solving the equation, we'll get integration of x equals to 0 to 1 of x plus 1 dx. After again, we have to apply the integration on dy. That is x square by 2 plus x of limit 0 to 1. After applying limits, higher limits and lower limits, we get I equals to 1 by 2 plus 1. Later, solving those equations, we get that I equals to 3 by 2. Hence, the region of the given integration I is 3 by 2. So, from the conclusion is this is how we solve the integration when it is given in a triple integrals along with its limits. So, when the limits are given, first we have to apply those limits, and later we have to, based on how many factors they are given, we have to integrate the factors one by one, and then we'll get the value at last, that is the region of integration. Thank you.